Here we go. Let's start out by talking imaginary numbers. Okay. We already know that if you have something like the square root of 25, the answer is a positive 5 or a negative 5. Because 5 times 5 is 25, and negative 5 times negative 5 is 25. The problem that we run into is when we have a root of a negative number. And so this is what mathematicians have decided to do. They have decided to do the following. The square root of negative 25 is the same as the square root of 25 times negative 1, which is the same as the square root of 25 times the square root of negative 1. Now, the reason that mathematicians have done that is because we already know the answer to square root of 25, and that's plus or minus 5. And so the question becomes, what do we do with the square root of negative 1? And what mathematicians decided to do is define I as equal to the square root of negative 1, and this is called an imaginary number. And so this negative 1 becomes I, and that is the answer. So, for example, if we had the square root of negative 9, should I just cut straight to the shortcut? Yeah. Okay. The square root of 9 is plus or minus 3. What's the square root of negative? I. Can you do the square root of negative 16? The square root of 16 plus or minus 4, the square root of negative I. That's all there is to it. Okay? Now, let's try some basic operations. What if we had 3i plus 4i? What do you think we would do with that? We would combine like terms. If you have 3 i's plus 4 i's, you end up with 7 i's. Okay? It's just like a variable. You know, if you had 3x plus 4x, you'd get 7x. Well, we're going to get to multiply in a minute. Let's do one more operation. What if we had 1 plus 3i minus 8 plus 4i? Well, we would combine like terms. So 1 minus 8 is negative 7, and 3 plus 4i is positive 7i. So it works like that. Okay? Alright, so the question was, what about multiply? Okay. Well, let's do this. let's say that you had I squared. Isn't that the same as I times I? Yeah? You can think about this either way. I squared is the same as the square root of -1. What happens when you square a radical? Get -1. Pretty crazy, huh? Okay, so what if we had 3i times 4i? We'd have 3 times 4 is 12, and I times I is I squared, and we already determined that I squared is -1. All right, one last operations problem. What if we add 3 plus 4i times 3 minus 4i? Isn't this like linear binomial times linear binomial? We do FOIL or distribute. 3 times 3 is 9. 3 times -4i, -12i. And now we distribute the 4i. What's 4i times 3? +12i. And what is 4i times -4i? -16i squared. Okay. Now let's start simplifying and combining like terms. -12i plus 12i cancel. Then we have -16, but I squared is equal to -1, so that changes the sign. So now you have 25. Have you run across this in the map testing?
Yes.
Yeah, you probably will have seen this. So now you know how to do it. All right, let's continue on to the next topic. Which is complex numbers. Okay, so complex numbers are, as they say, they're complex. They consist of two parts. They look like this: A plus BI, where the A portion is a real number and the BI portion is an imaginary number. So an example of a complex number would be something like 3 plus 4i. Now I'm going to go back to the previous page. When we were multiplying these, we were multiplying complex numbers. Okay? All right, so let's talk about imaginary numbers. We've already defined what those are. So we know that I equals the square root of -1, and that I squared equals -1. So we know that. There are two different kinds of real numbers that are going to be important to us as we move forward with polynomials. The first kind of real numbers are called rational numbers, and the second kind of real numbers are called irrational numbers. Now, within the rationals, there are really three types. You can have integers, which are numbers like -2, -1, 0, 1, 2, and they go forever in both directions. And we can have fractions. And it turns out that there are two types of fractions. The first is called terminating, and an example of this would be 1/4. Because when you divide this, you get 0.25, and the decimal stops after the 5. The next type of fraction is repeating non-terminating. An example of this would be 1/3, because when you convert it to a decimal, it goes 0.33333. It repeats and it goes forever. It never terminates. It never stops. Okay? So the rational numbers are integers and fractions that are terminating or repeating. Okay, the irrational numbers are non-terminating and non-repeating. An example of this would be pi, which is 3.14, and then it continues forever and never repeats. E, which is 2.718 and continues on forever and never repeats. But more importantly, for us, are numbers like this. The square root of 2, which is 1.414, and it continues forever without repeating. The square root of 3, which is 1.732, and continues forever without repeating, and so forth. Now, when we write square root of 3, we call this an actual value, because by stating or writing square root of 3, we are including all the decimal points out to infinity. But as soon as we write a decimal, it becomes an approximate value. Because no matter how many decimals we write, there's always one more, because it goes on for infinity. So there's no way to write the number with decimals. It's always approximate. So this idea of actual and approximate is going to be important for us. Okay? Next. The next thing is my apology that there are lots of notes today. But I will preface it by saying this is the last thing that we're going to do, and then you'll have the rest of the hour to work on assignment, and I don't think the test tomorrow is going to take very long, so you'll have all day tomorrow after the test. Okay? Alright, let's do a quick quadratic formula. Now, in our warm-up, or our formative assessment, we saw that the results from the quadratic formula gave us the same roots of a polynomial as when we factored it. And so for our purposes, we are going to use the quadratic formula to find roots of a quadratic polynomial that can't be factored. So, for example, y equals x squared minus 3x minus 1. If we are to find the roots of this quadratic, the first thing we want to check and see is, can we factor? So always ask yourself, can we factor? Any ideas? Are there two numbers that multiply to -1 and add to -3? There aren't. So if the answer is no, then we're going to use the quadratic formula. So I'm going to start by writing y equals ax squared plus bx plus c. And then we're going to rewrite this quadratic trinomial. 1x squared minus 3x minus 1. And we are going to identify the a, the b, and the c values. So the coefficient in front of the x squared is 1, so a equals 1. The coefficient in front of the x is b, so b is -3. The constant is -1, so c is -1. So now we're going to rewrite the quadratic formula using parentheses. x equals minus b plus or minus square root b squared minus 4ac all over 2a. And we substitute in our a, b, and c values. X equals minus b negative 3 plus or minus square root b squared negative 3 minus 4a 1 c negative 1 all over 2a 1. I fully expect to hear lots of singing and humming on test day, homework day. Alright, so solve this in 3 chunks. Negative negative is positive 3. 2 times 1 is 2. What is negative 3 squared? 9. Okay. What is negative 4 times negative 1? 4. So we have 9 plus 4 is square root of 13. Is it possible to reduce or simplify square root of 13? It is not. So that means we have an irrational solution. Okay? So our 2 answers are parentheses 3 plus the square root of 13 divided by 2 and parentheses 3 minus the square root of 13 divided by 2. Okay. These are the actual values of the roots or the x-intercepts. So if a problem ever asks you for actual value, this is the number that you want to give. But if you have to graph this, then we have to get the approximate values. So what I recommend is you put these in your calculator just like this with the parentheses, and you should find this is approximately 3.3 and this is approximately negative 0.3. And you should make sure that you can get that with your calculator. Okay? Now, let's graph our polynomial. Okay? So go back to the original and look at the lead coefficient. It's positive. Is the right side up or down? Up. And the degree is even, so the left side is up. And the constant is negative 1, so the y-intercept is negative 1. And now, we couldn't factor this to get the x-intercepts, but we could do the quadratic formula, and our approximate values of the roots are 3.3 and negative 0.3. And so our polynomial graph looks something like that. And with that, I think that is plenty. So we'll call that note.